Hello everyone, welcome back to my YouTube channel. Myself Ankita, studying in Sri Venkateswara College of Engineering, Bangalore. Today I am going to explain about some topic of the mathematics. Subject code is BMATS 101. Topic is application of polar coordinates, curvature and radius of curvature. First of all, I am going to explain about the application of polar coordinates. Polar coordinate system is a two-dimensional coordinate system in which each point on a plane is determined by a distance from reference point and an angle from a reference direction. The reference point analogous to the origin of a Cartesian coordinate system is called the pole, and the ray from the pole in the reference direction in the polar axis. The difference from the pole is called the radial coordinate, radial distance of or simply radius, and the angle is called as the angular coordinate. Polar angle or angle in polar notation are generally expressed in either degree or radius. 2 pi radian begin equal to 360 degree. Independently introduced the concept in the mid 17th century through the actual term polar coordinates has been attributed to Giorgio Fontanus. In the 18th century, the initial motivation from the introduction of the polar system was the study of circular and orbital motion. Application: polar coordinates are two-dimensional and thus they can be used only where point position lie on a single two-dimensional plane. They are most approximately in the context where the phenomena begin consider is inherently tied to direction and length of the center point. For instance, the examples above somehow elementary polar equations to define curve such as the Archimedean spiral, whose equation in the Cartesian coordinate system would be much more intricate. Polar coordinates are used too often in navigation as the destination or direction of travel can be given as an angle and distance from the object being considered. For instance, aircraft use a slightly modified version of the polar coordinate for navigation. In this system, the one generally used for any sort of navigation, the 0 degree ray is generally called heading 360 and the angle continue in clockwise direction rather the counter clockwise as in the mathematical system. Heading 360 corresponds to magnetic north, while heading 90, 180, and 270 correspond to magnetic east, south, and west respectively. Curvature. Curvature of a circle. A circle of radius r has a curvature of size 1 by r. Curvature. The act of curving, the state of being curve. The ratio of the change in the angle of a target that moves along curve from point to point. The limit of the ratio of the change in the angle of a target as r length approaches 0. The reciprocal of the radius of a circle. Let c into r is equal to r vector. Be a space curve and P be a point on it. Then curvature at P is defined as ratio of rotation of target change in the direction of target at P Its magnitude is denoted by k and identified by k is equals to limit s turns to 0 rho theta by s is equals to d theta by ds. The angle between the tangent of at point P and Q on the curve along R length delta S. More precisely, curvature is scalar measure of bending nature of the curve, degree of curving in a line, change in the direction of the target line, heart rate of rotation of tangent line from point to point, change in principal normal along tangent direction. Note: first one is straight line has zero curvature. A circle has constant curvature. A circle helix has constant curvature. The curvature of a small circle is large and vice versa. The radius of curvature is denoted by rho, that is 1 by k is equals to rho. Curvature measures the rate at which a space curve change direction. The direction of the curve is given by the unit tangent vector. T into T is equals to R into T by mod of R vector into T, which has length 1 and is tangent to R vector into T. The picture below shown the unit tangent vector T and curve R is equals to 2 cos t, comma sin t, comma 0 as serval point. Obviously, if R vector t is a straight line, the curvature is 0. Otherwise, the curvature is non-zero. To be precise, curvature is defined to be the magnitude of the rate of change of the unit tangent vector respectively to r length. K is equals to dt vector by dt mod dr by dt. Radius of curvature. Radius of curvature for a curve is defined by curvature. We mean the degree of bending of a curve. The formula of the radius of curvature is 1 plus dy by dx whole square is whole square by 3 by 2 divided by d square y by dx square. Thank you for watching my video. Please like and subscribe my YouTube channel.